Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the disc below, or on our website padhaikarlo.com. Today's topic is forming a quadratic equation when its roots are given, the reverse process or actually solving one. Let's begin. If alpha and beta are the two given roots of a quadratic equation, the equation itself can genuinely always be written directly as x squared minus the sum of the roots times x plus the product of the roots equals 0, or more compactly, x squared minus alpha plus beta x plus alpha beta equals 0. This formula is derived directly from the fact that a quadratic with roots alpha and beta can genuinely be factored as x minus alpha times x minus beta equals 0, and expanding this product directly gives x squared minus alpha plus beta x plus alpha beta. So the entire process of forming the equation reduces to genuinely just two simple steps: calculate the sum of the given roots, and calculate the product of the given root. Then substitute both directly into this standard formula. As a genuinely direct example, to form the quadratic equation with roots 3 and -2, the sum is 3 plus -2, which is 1, and the product is 3 times -2, which is -6, so the equation is x squared minus x minus 6 equals 0. When the given roots involve irrational numbers, like 2 plus root 3 and 2 minus root 3, or complex numbers, like 3 plus 2i and 3 minus 2i, these conjugate pairs are genuinely especially or imaginary parts always cancel out cleanly in both the equation with entirely real, rational coefficients. For 2 plus root 3 and 2 minus root 3 specifically, the sum is 4, and the product is 2 squared minus root 3 squared, which is 4 minus 3, equals 1, giving the equation x squared minus 4x plus 1 equals 0. A genuinely frequently tested JEE variant asks you to form a NEW quadratic equation whose roots are related to the roots of an original equation, in some specific way, like alpha plus 1 and beta plus 1, or alpha squared and beta squared, or 1 over alpha and 1 over beta. The strategy here is genuinely always the same. First, find the sum and product of the original roots using the known formulas: sum equals -b over and product equals c over. Then compute the new sum and new product for the transformed roots specifically, and substitute those into the standard formula. A frequently tested trap involves genuinely forgetting that if the leading coefficient isn't required to be exactly 1, any constant multiple or x squared minus sum x plus product equals 0 is also a genuinely completely valid equation with the exact same two roots. So k x squared minus sum x plus product equals 0 works for any non-zero k. Holographic kite larking Michelle, a Philadelphia Nessifer, Prince teacher and Yale ka Phil Filler, piece of job, Philophone Avanci Philidid Philadelphia. A genuinely frequently tested JEE variant asks you to form a NEW quadratic equation whose roots are related to the roots of an original equation. Let's recap. To form a quadratic equation from its roots, use x squared minus plus the product of the roots equals 0 derived directly from factoring x minus alpha times x minus beta. Conjugate irrational or complex roots always produce real, rational coefficients, since the irrational, or imaginary parts, cancel in the sum and product. For transform root problems, always find the original sum and product first, then compute the new ones for the transformed roots before substituting. That's forming a quadratic equation from its roots. Keep the sum and product formula and the transformed roots strategy sharp. They turn this into a fast mechanical process. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.